This is the standard atomic notation for the element neon. This is the symbol for neon. This is the average atomic mass for neon rounded to the nearest whole number. And this is the atomic number for neons.
This is the nucleus part of the atom, and the rings surrounding it are the orbits. Inside the nucleus, there are protons and neutrons located. In this case, there are 10 protons and 10 neutrons. In order to find the amount of protons, it is the atomic number. In order to find the amount of neutrons, it is the mass number minus the atomic number. And the electrons are always the same as the protons. So there is 10 electrons because there's 10 protons.
The electrons are located on the different orbits. The first orbit can hold up to 2 electrons at the top, and then from there you put the next electrons onto the second orbit, and it can hold up to 8, and all the other orbits can hold up to 8.
So our first orbit has 2 electrons, and our second orbit would hold the rest, which is 8, and they would go in a clockwise order around the orbit.
This is the Bohr-Rutherford diagram of neon. This is the electron dot diagram. You can draw the electron dot diagram by making the Bohr-Rutherford diagram and then looking at the valence shell, which is the outermost shell, and it's the number of valence electrons on the valence shell in the exact same location that they were on the valence shell in the Bohr-Rutherford diagram. So here, if you look back to our last slide, you can see that the outermost electrons were in groups of 2 like that on each point.